For this question, we're given a table, and we want to determine if this table represents a linear function or not. Now, the way you can tell if it's linear is that if I find the slope between any of these points, I should get the same number every single time. That's going to tell me it's going to be linear. So we can do that for this one. Let's first start out with, we have 1 point, -2, 10. And let's just use the next one, -1, 7. And I'm going to put this into my slope formula. So I'm going to go ahead and label this x1, y1, x2, y2. Your formula for m is y2 minus y1 over x2 minus x1. Let's do that for this one. We're going to do y2, which is 7, minus y1 is 10, divided by the difference in the x's, -1 minus -2. We get -3 on top and a 1 on the bottom, which means that we get -3 for the slope. Okay, but we have to show that is true for the other points as well. So let's go for -1, 7 and 0, 4. We're going to do that as our next two sets of points. So x1, y1, x2, y2. Again, we're going to find the slope, change in y over change in x. We're going to do 4 minus 7 over 0 minus -1. And, okay, we get another -3 again. So now we get that. Let's try one more. Put that over here. The last one set of points is 0, 4 and 1, 1. We'll label those x1, y1, x2, y2. Put it into our slope formula. Change in y over change in x. We're going to do 1 minus 4 on top over 1 minus 0 on the bottom. And we get -3 again. So we've done that for all these sets of points, and we get the same slope every single time. We get -3. Because of that, that's going to tell us that this is going to be linear. Now let me show you another way that you could quickly see if it's linear. Notice that if I go from -2 to -1, I have to add 1 to get to here. I have to add 1 to get to this, add 1 to get to that one. So I'm adding 1 every single time to all those. On the bottom, I'm looking for if the same thing is happening with all my points on the bottom. If I have 10 minus 3, I get 7. 7 minus 3, I get 4. 4 minus 3, I get 1. That would be another way that you could tell what's happening. So the y is going down by 3 every time, as x is going up by 1 every time. So that would be saying the same thing. The slope would be -3. Now, we have to also find the linear function. So we're going to use y equals mx plus b. We're going to use that format. Now, the slope, the m, is -3. Now, what about the b? Now, the b represents the y-intercept. And yeah, I could take any of these points and I could plug it in and figure that out. However, this point right here, this 0, 4, that actually is a y-intercept that they gave us already. It's because the x value is 0. Whenever an x value is 0, then it's going to be a y-intercept. So 4, that's our b value. So when I put this in on this side, I get -3x plus 4. Now, I don't want to put a y in there because it says linear function right here. So linear function means I need to write it in the proper function notation. Now the function notation here is going to be f of x. So that's how you want to write your answer. Because it specifically asks for a linear function, I don't want to put a y. Instead, I'll use the function notation f of x. So f of x is equal to -3x plus 4. For this next one, it's the same thing again. We have a table provided. We want to determine if it's linear or not. Now what I told you on the last problem that you can do is you can actually look to see if you have the same difference going on here like we had before. So x is going up by 1 every time, as we see there. But this goes from 2 to 0, so we're going down by 2. But then I go from 0 to 0, nothing changes. And then I go from 0 to 2, I'm going up by 2. So nothing is consistent here on that one, which means that if I wanted to find the slopes between each of those like I did in the previous problem, I could certainly do that. However, because I already noticed that there's no common difference on these here, I have 2, 0 to 0 to 2, it's going down and going up, same. I can tell this is not linear, and so because it's not linear, I'm not going to be able to determine what the slope is. I can find slopes through individual points like that, but they're not going to be the same. So in the notes, I did that actually. So if you look at the notes that accompany this section, you'll see I went through and did that work on there, and you'll see that because of that reason, the slopes are all different. That's another way you can tell it's not going to be linear.